Today I'm gonna talk about this Hyrel Hydra 21A. So it's an open source 3D printer, which means we can use this 3D printing for different kinds of like 3D printing technique. Like you're familiar with fuse deposition modeling, FDM, or even like ink-based 3D printing techniques. We can use all those techniques in this single one printer. And even we can also use our custom designed nozzle with this open source printer to print different structures. So with this Hyrel Hydra 3D, we have been working on mainly three techniques of 3D printing. One is the usual FDM, which is like a filament based 3D printing techniques to print like different structures. For example, like we printed these kind of like nozzle holders using this Hyrel Hydra structures. And apart from this usual filament based 3D printing, we also use like an ink based 3D printing technique where we used to prepare like different polymers. So most of the polymers we can't use in terms of like melt extrusion, so we need to dissolve them in a certain solvent and make it into like a viscous ink based solution, and we can use that ink based solution to 3D print using this Hyrel Hydra. So one of the head from Hyrel is this SDS 60, where you can use like a 60 ml syringe and you can fill them with like few ml of like solutions of your polymers or whatever, like polymers and fillers or different kinds of material composition, and you can print different structures or patterns however you want, and you can use them for different applications. So one example with this ink based 3D printing technique is I have used a polymer called PVA. You can see this is the printed structures. We have printed like different structures like honeycomb patterns, like a spiral structures, like a porous metal sheets, and like a hard structures. So these are all printed with the polyvinyl alcohol PVA solution, like water based ink. And I've used this 3D printed structure for different applications. So for instance, in this scenario, I have converted them into like a completely like carbon structure. I've just burnt them in an inert atmosphere and converted them into completely carbonized 3D printed structure. So in that case, you can have like a 3D printed highly conductive carbon structures. You can use them for different applications in terms of like mechanical, thermal, or electrical, different kinds of applications. So this is just an example, and we can print like much more different structures with different material compositions, and we can able to tune properties according to our needs. And we also have a custom designed nozzle from our group, which is called as like a multi-phase direct ink writing, through which we can use like a two different material and print both at the same time in terms of like layered structures. So we have designed this nozzle, and we have used a custom designed holder for Hyrel, and we can just easily fit this in, and then we can use this in the Hyrel 3D printer like this, and we could yeah, that's it. And so now the custom design nozzle with the Hyrel 3D printer is like ready to print. So we can use some customized simple G code patterns, and then we could able to use our nozzle to print like different structures. And this pen camera was also provided from Hyrel to capture like high resolution like a real time 3D printing videos. So this is the pen camera over here, and you can adjust the lightings and then the zoom you want to keep during the printing. So usually if we just use the mobile phones, it's going to be like a stationary, but in terms of this kind of like a in situ printing, we could able to analyze the printing resolutions, and we could do a lot of like machine learning based like printing using this like in situ monitoring of printing. And one sample video that was taken using this pen camera I can show over here. So this is the video that was taken using this pen camera using our nozzle in the Hyrel 3D printer. You can see like different pattern structures that was captured using that Hyrel pen camera. You can see a very clear printing lines, and then you can see like a more high resolution videos. We can later use them for machine learning purposes to analyze the printing parameters and so on.